In this series of videos, we're going to solve different types of equations other than your linear and quadratic. They may be similar, but they're considered different types because of, for instance, our absolute value types. So we'll be solving absolute value types, quadratic in nature types, and even exponential types. Let's start with absolute value types. We're going to solve 2 times the absolute value of x minus 4 minus 5 is on the outside of the absolute value equals 9. Our first step when solving absolute value types is to isolate the absolute value. Isolate the absolute value. So I'm going to rewrite the problem. 2 times the absolute value of x minus 4 minus 5 equals 9. When I rewrite the problem, it helps me understand the problem just a little bit better. And step 1 is saying get the absolute value all by itself. So kind of think of it as a different variable, maybe 2 times u minus 5 equals 9. So what would you do to get this part of the expression all by itself? Well, I would add 5 to both sides, and then I would divide by 2. So I'd have 2 times the absolute value of x minus 4 equals 14, and then I would divide both sides by 2 because I undo the addition subtraction first, and then I undo the multiplication. That's going to give us the absolute value of x minus 4 equals 7. So the absolute value of 7 will equal 7. The absolute value of negative 7 will equal 7. I'm going to put that negative 7 in green. So that means that x minus 4 could equal 7. That means that the x minus 4 could equal negative 7. So we create 2 equations. You take the expression inside the absolute value and set it to the positive value, and it's negative, So we end up with x equals 11 and x equals negative 3. And those are the 2 possible solutions to this absolute value equation. So let's redo our steps. Isolate the absolute value, and then 2, it's important that you write this down, create 2 equations, okay? 2 equations. So you don't change the sign of the inside part of the absolute value. You don't change the sign of the expression inside the absolute value. You change the sign of the value on the outside. However, know that absolute value is equal to distance. So absolute value equals distance, and distance is always positive. Okay, here's one for you to try. Go ahead and see if you can isolate the absolute value and then create your 2 equations and solve. Okay, hopefully you pressed pause and you're ready to reveal the work to see if it's equivalent to what you've done. We're going to subtract 1 from both sides, so we get negative 12, and then I'm going to multiply both sides by 4 and divide by negative 3. So we're going to end up multiplying both sides by the reciprocal of negative 3/4. So we have the absolute value of 2x minus 1 equals a positive 16, which is a good thing because the absolute value has to be 16. So 2x minus 1 could equal positive 16. 2x minus 1 could equal negative 16. So 2x equals 17. X equals 17 over 2. 2x could equal negative 15. X equals negative 15 over 2. Now another way to think of this would be to multiply each term in that original equation by 4. So you could clear the fraction. -3 times the absolute value of 2x minus 1 plus 4 equals -44. You can always clear the fraction if that makes you feel more comfortable. Then when you divide both sides by that -3, you'll get -16. I'm sorry, +16. If you ended up with -16, there wouldn't be an answer because the absolute value is distance, and absolute value has to equal a positive. So when you have that absolute value isolated and all by itself, it needs to equal a positive value. Okay. I'm going to come back to this next example in another video just to keep them shorter, but I want you to take a look at where we're going. We've got the absolute value equals an expression that has a variable in it. So this one we're going to handle just a little bit differently.